All right, y'all, here are your 4.3 notes on solving systems of equations by substitution. So for the past few days, we've been solving systems of equations and inequalities by graphing. Today, we're introducing another method to solving systems of equations, which is substitution. There are a couple steps to take when we're using substitution. Step 1 is to solve one equation for x or y, okay? And when we're doing this, we're looking for the single coefficient. Okay, and what I mean by single coefficient is that I'm looking for the variable that has 1. That's by itself, essentially. Okay, and then we're going to substitute that single coefficient expression into the other equation and solve for the variable that's left. Okay, and then step 3 is to substitute your answer into the revised equation from step 1 and solve for the other variable. Okay, so if these steps aren't making sense now, I'll walk you through them and kind of put some of the pieces together. So looking at example 1, step 1 says to solve for x and y, or x or y, we're looking for the single coefficient of 1. So we're looking for the variable that's by itself. Okay, y has a coefficient of 1, right? It's by itself, it's isolated. So we found step 1. Step 2 is to substitute this expression into the other equation and solve for the variable left. Okay, so I'm going to substitute this part of my expression into this equation. Right? So see, instead of y, I substituted what y was into this equation. Okay, so now I can go ahead and solve this for x. So first I distribute, this becomes 2x plus 18x equals negative 20. Okay, I combine like terms. I divide by 20 on both sides. And this becomes x equals negative 1. Okay, so that's step 2. Step 3 is going to be to plug this x value back into our original equation and solve for y. So I'm going to plug this x value, which is negative 1, back into this equation, and then I can solve it to give me my y value. So then my solution becomes these two numbers that I found for x and y. All right, so looking at number 2. Again, step 1 is to find the single coefficient. Okay, that's isolated by itself. That's y. So we found that. Okay, step 2 is to take that part of our equation and substitute it into the other. So instead of y in the second equation, I can plug in this other part. Okay, then I can solve for x. So I'm going to distribute the 8 to everything inside of that parentheses. So that's 8 times x, which is 8x. That's 8 times 9, which is 72. Okay, then I can combine like terms. That 8x and 3x combine to make 11x. Okay, then I can solve just like I normally would. Subtract 72 on both sides. This leaves me with 11x equals negative 77. I can divide by 11 on both sides, and I get x equals negative 7. Okay, then step 3 is to take that x value and plug it back in to our original equation. And when I do that, I find that y equals 2. So my solution is negative 7, 2. Okay, so what you're going to do now is you are going to pause the video. Okay, you are going to try number 3 on your own. Instead, on number 3 of y, we have x here. Okay, so you're going to plug that x into the second equation, okay, just like we did on examples 1 and 2. And then when you're done, you're going to check in with the sub. They'll have the answer key for you. And once you're done and you've got number 3 all good, you can move on to number 4. But again, if you're still confused about what we did on numbers 1 and 2, you can always go back and rewatch those. Okay, so now we're moving on to number 4. Number 4 looks a little bit different, okay? It doesn't start with a y equals or an x equals either equation. But again, like step 1 says, we are looking for the single variable, for the single coefficient, right? So that single coefficient is located here. However, it's not isolated. So what we need to do first is I need to isolate that single coefficient, meaning I need to get y by itself and move everything else to the other side. So I'm going to do that by subtracting negative 2x. Okay, when I do that, I get y equals negative 2x plus 9. So that's step 1. I can take this part of the expression and plug it into the other equation. Okay, and then I can solve for x. First, I need to distribute. Negative 3 times negative 2x is positive 6x. Negative 3 times negative 9 is negative 27. Okay, then from there, I combine like terms. 2x and 6x combine to make 8x. Okay, then I can solve like I normally would. So I can add 27 on both sides. Bring down 8x. Negative 11 plus 27 equals 16. I divide by 8 on both sides. And I get x equals 2. Okay, so now I know what my x equals. I need to take that and plug that back into my original equation. Y equals negative 2x plus 9. I know that x is 2. Negative 2 times 2 is negative 4. Negative 4 plus 9 gives me a y value of positive 5. So then I take those two numbers and I... All right, so looking at number 5, I can see my single coefficient of x, but I need to isolate x. So that means that I need to get 5y to the other side. When I do that, I get x equals negative 5y plus 4. So I did step 1. Now I need to take this x value and plug it in to my second equation. So this becomes 3 times negative 5y plus 4 plus 15y equals negative 1. I distribute to both sides of my equation. So this becomes 3 times negative 5y, which is negative 15y, 3 times 4, which is 12. Okay, and then I still have my 15y over here. Okay, I combine like terms, and when I do that, negative 15y and positive 15y cancel these two out, and I'm left with 12 equals negative 1, which 12 does not equal negative 1. Okay, so what happens here is that we have no solution. Okay, so now what you guys are going to do is you are going to do example number 6 on your own. When you're done, you're going to check in with the sub. Once you've gotten number 3 and number 6 checked off, then you can go ahead and finish your Get More Math from earlier this week, 4.1.